number 4 on the 4A worksheet, we have a gorilla, a big giant gorilla, which we're going to approximate like that, hanging from 2 vines. Now, these vines, and I always screw this up every time I do the problem, these vines make a 30-degree angle with the vertical. And I always want to have that 30 coming out of the ceiling. It's not. The 30 is with the vertical, not the horizontal. Okay, what we know about said gorilla. We know that there is some force of gravity on the gorilla, F of G, which is going to equal its mass times gravity. Okay, and its mass is massive. We know that we have, running right back along these cables, what we call force of tension. Okay, we have a force of tension on each cable. Now, let's look at our sum of forces for this. So first of all, let's address and then discard sum of forces on the x. Helps to break this down into force of tension on the y, force of tension on the x, sum of forces on the x is equal to force of tension on the x1 plus force of tension on the x2. Furthermore, is this gorilla moving side to side? No. So the sum of forces on the x is 0. You looked alarmed at the force of tension 1 and 2? Were you? Okay. Remember that we have 2 cables. Each of them has got equal tension because the angles are the same. So,
like, if one angle would be like 40 or something,
then they would have different amounts of. Well, on the x it would still be 0 as long as the monkey isn't moving.
But on the y it would be different, right?
Well, they'd have different magnitudes on the x and the y. But as long as it's not moving, they still sum to 0. Okay? So for right now, we're gonna walk away from this. There's nothing here we can really use. Let's now look at the y-axis. So, sum of forces on the y equals the force of tension on the y, 1, so on the first cable, plus force of tension on the y, 2, plus the force of gravity. And again, what does it equal? 0. Okay. Now, because these angles are the same, what do we know about force of tension 1 and force of tension 2? They're equal to one another. So Ft1 equals Ft2. Therefore, this whole thing is 2 Fty1 plus F of G equals 0. Okay? Now we just need to create an expression for F of Ty. Well, if we look at this, we know that F of Ty has to be equal to this. And if this angle is 30, remember we can transpose vectors parallel to themselves. So this is cosine of 30. So here, we'll do this over here. F of Ty equals cosine 30 Ft. So we have 2 times Ft times cosine 30 plus Fg equals 0. So now we're in a position to solve for the force of tension. Okay? So Ft equals negative F of G divided by 2 cosine 30. And from there you can plug. It gets a little bit hairier when we get to the next one, which is fine. It's okay. Yeah. I'm gonna.
I still get 1700. I get 1755. If it was round up, wouldn't it?
71760 then.
Yeah.
You get 1760 with sig figs.
Yeah.
Yeah,
Is it-
that's the answer. Here's what I'm going to suggest. This is typically this specific problem. Like I remember Zorba the Mastiff because this specific problem usually gives people big headaches, and it's not that hard.
This one is sort of nasty.
But conceptually, oh, this is the gorilla. I'm sorry, it's the Mastiff that gives people spasms. But it kind of starts with the gorilla. If you're struggling with this one, copy down this methodology, plug it in, solve it, then go back through it and try to get that on your own. Okay? So I'm going to stop video.